data analysis past questions we'll do here. So since we do not have past questions, we'll take material questions to our exam style. A school teacher is investigating the claim that the class size does not affect GCSE results. His observations of 9 GCSE results of classes are as follows: x1, x2, x3, x4, y1 and so on. Summation C. Calculate the Pearson's, Spearman and Kendall and use Pearson's correlation coefficient to test whether the data agrees with the claim size does not affect GCSE results. And following the investigator, teacher concludes bigger class sizes improve GCSE results. Comment on the statement. So let's see how they've written this. 10.2 I'm coming here. So first we have to calculate. So question 1, we have our Pearson correlation coefficient. Okay, some spelling errors are there. So first, alt equal to S underscore CC, which is equals to backslash sum C square minus backslash summation of C. We do a whole square to this and divided by n, which is equals to 6884 minus 238 square divided by 9, which is equals to 590.2222. Okay, we'll just do one change, small is centered as crew, has to be left and so. Okay, now this is there, then S underscore CP is equals to backslash summation CP minus in brackets backslash summation C backslash sum P brackets close divided by N, which is equals to 983 minus 238 into 33.4 divided by 9, which is equals to 99.75556. Okay, and alt equals to S underscore PP is equals to backslash of sum CP minus of backslash of sum P square minus backslash of sum P whole square divided by N, which is equals to 149.62. The values are given in the question. 33.4 square divided by 9, which is equals to 25.66889. Okay, so this is there, and therefore R is equals to S underscore CP divided by SCC into SPP, square root of both of these. So both, okay, is equals to 99.7556 divided by SQRT of 590.222 into 25.66889, which is equals to 0.81045. Okay, so this is the Pearson's correlation coefficient. Next we have a Spearman rank correlation coefficient. So Spearman rank correlation. So here we know we make tables in our copy. So here also we'll make tables ranking the data and so on. You can just basically insert a table which is of 1, 2, 3, 4 column. Okay, 4 column and say around 4, 5, 9, 10 rows. Okay, we'll just insert more whatever we like. So we need class students in class C, then average GCSE point P, and then you have differences. You have your x1, then 9, 8 and 1, the difference, x2, 7, 6 and 1. We have x3, which is 4, 3 and 1, x4, which is 2, 2 and 0, x5, which is, no, we have y1, which is 8, minus 9, or 8 and 9. So this becomes minus 1. Here we have y2, which is equals to 6, 7, then minus 1. Then we have y3, where we have values is 5 and 0. Then we have y4, where we have 3, 4 and minus 1. And then we have y5, where we have 1, 1 and 0, the difference. Okay, this is easier to make when you have the values. I'm just copying, that is why it took me some time, but when you have your question paper you can directly do it. So r, then therefore r underscore s is equals to 1 minus 6 into 6 divided by 9 into 9 square minus 1, okay, which is equals to 0.95. And then we have our Kendall. Again for Kendall we'll make a table. So Kendall correlation coefficient, and I'll just, what I'll do is I'll copy this table so that I don't have to write the values again. Okay, students in class C and so on. So here we have students in class C, so they have written in some other way again, x1, x2, x3 in concordant pairs and so on. So I'll just see x1, 9, 8, and here we have one concordant pairs you need, and one more column. So we'll just right click, insert columns to the right. You need one column which is discordant pair. So here we have for x1 is 0 and discordant pairs is also 0. For x2 you have 2 and 0. x3 we have 5 and 0. For x4 I have 7 and 0. y1 I have 2 and 1. y2 I have 2 and 1. y1 is 0 and 1. y2 is 2 and 1. y3 is 4 and 0. y4 is 5 and 1. And 5 is 8 and 0. So these are the pairs we have this. Then you can arrange it in your rank and order and so on. So totaling, we have been given alt equals to n underscore c is equals to 33. Alt equals to n underscore d is equals to 3. So therefore tau, so how to write tau? TAU. So this becomes tau is equals to 33 minus 3 divided by 9 into 9 minus 1 divided by 2 and bracket close. So this is 9 into 9 minus 1 by 2, which is equals to 0.83. Okay, and the last part says test whether the correlation class size matches. So let's come down. Test. testing part. So part B, test whether the class size does not affect GC. So we are testing h0 is equals to backslash row is equals to 0 versus h1 row not equals to backslash any not equals to 0. Okay, so this is there, and the test statistic is alt equals to r backslash sqrt of n minus 2 divided by backslash sqrt of 1 minus r square space follows t underscore n minus 2. Okay, and then we used to have our next step. We have to calculate the test statistic for our tn minus 2 variable. So alt equals to under h0, the ts is 0.81405 backslash sqrt of 7 divided by backslash sqrt of 1 minus 0.81045 square, which is equals to 3.660. Critical value is this is greater than critical value at 0.5% level of significance and 7 degrees of freedom. Okay, there is sufficient evidence to reject. There is sufficient evidence to reject it not at 1% level of significance. And in the comment portion, I'm not writing the comments. It is sheer theory, so this is normal typing. Okay, next question 10.3. So we'll do 10.3 now. University wishes to analyze the performances of its students on a particular degree course. It records the scores obtained by sample of 12 students at entry to the course and the scores obtained in the final examination by the same students. The results are as follows. Student A, B, C, D, E, F, entrance exam X%, 8653, final score, and summation X and summation Y and so on. Okay. Explain why Spearman and Kendall's rank relation cannot be calculated here using the simplified formula. So again theory hai. So the ranks from the highest to lowest differences are as follows. So they have done this table. You can draw the table as I have shown you, and since we have tied ranks, you cannot use the simplified formula. Since we have tied ranks over here, you rank here. So I'll just write it since it's given. So question 2, you have tied ranks, so you have to rank here. So again insert a table, 3 and any number of this you need, by tab you can enter. So student, and then you have entrance exam, score X and final score Y. Okay, so student is A, B, C, D, E, F, G, H, I, J, K and L. Okay, so these are the students and they have the marks over here. So 11, 1, 7, 4, 5, 9, 6, 10, 12, 2, 3 and 8. And similarly for your final score y, we have 8, 1, 7, 4, 5, 8, 10, 12, 11, 1, 3 and 5. So these are the ranks from lowest to highest. And since we have tied ranks, we cannot use simplified formula. Okay, as simple as that. You can see there is this 5 appearing 2 times over here, whereas there is no tied rank, but here there is a tied rank, so we cannot use. Next part to this is calculate the Pearson's correlation coefficient and test whether the data. So again we have to calculate the Pearson's correlation coefficient. So Pearson's correlation coefficient part 2, alt equals to s underscore xx is equals to 60016 minus 836 square divided by 12, which is equals to 1774.67, and alt equals to again SYY is equals to 63603 minus 867 square divided by 12 is equals to 962.25, and alt equals to S underscore XY is equals to 1122. So this is there. So therefore R is equals to S underscore XY divided by SQRT of SXX into SYY underscore SXX into underscore SYY space which is equals to 1122 divided by SQRT of 1774.67 into 962.25 brackets close is equals to 0.85860. Okay, and then testing we need to do, test whether this is there. So again alt equals to h naught is equals to / rho is equals to 0.75, and alt equals to h underscore 1 is / rho is equals to 0 is not equals to 0.75. Two-sided test again. So now if alt equals to h naught is true, then TS Z underscore R has normal Z underscore rho comma 1/9 distribution, where Z underscore / rho is equal to tan H inverse to 0.75, which is equals to 0.97296. Okay, the observed value of TS is alt equals to tan H inverse of 0.85860, which is equal to 1.2880, which corresponds to alt equals to 1.2880 minus 0.97296 divided by / of SQRT of 1/9, which is equal to 0.945 on the normal 0, 1 distribution. So hence, since this is less than 1.96, the upper 2.5% of normal 0, 1 distribution, hence we have insufficient evidence to reject H0 at 5% level. Okay, so this is your data analysis.